Hello class. Today we're going to go over 5.4 vectors. So first thing I want to talk about is the perspective of a vector. So typically a vector starts with a point, and this point is called the initial point. And then we're given some direction to another point, and that other point is the terminal point. And vectors, they have to have magnitude and direction. So here the direction is clearly given. It's going from the initial point to the terminal point. The magnitude is its length. So the 5 here would represent the magnitude of this vector. So the initial point headed towards the terminal point with a magnitude is a vector, stressing that it has magnitude and direction. Okay, this next point that we're going to talk about is the vectors have addition. It's commutative, so this is important. So if I give you two vectors and I start with an initial point and give it some distance, and I call that vector v, and then I have some other vector and I'll call that w, the resultant that goes from the initial point to the terminal point of w is this. This is the resultant. This is v plus w. Now, one important thing to note is that we could also have gone w to v. So if we would have gone w to v, it would have gone this way, and then terminal point, and then gone this way. And so going this way, this would be w, then v. So that would be the perspective of w plus v. We see that the resultant is exactly the same here. That's the critical piece here. And that's why v plus w is equal to w plus v. It's how we start to where we end up. The path that we take matters. With the associative property, it's a little bit more funky. So let's say that I start off with some terminal point and I go up u, and I'm going to use different colors just so you guys can see this, and then a terminal point, and we'll call that v. And then another terminal point will go w. And so what ends up happening here is this vector here in green, this vector here in green would be u plus v. So then u plus v plus w, I'm going to try to use something bright for you guys to see, is this piece here. So this vector here is the resultant of u plus v plus w. And if I did another vector, let me use dark blue, that went this way. This here would be this would be v plus w. And so you see how you're going to go in this direction. You're going to go u and then plus v plus w. And so the resultant for that one, going that path, going in this direction to the end, would be u plus v plus w. And we see that these two are one and the same. The associative property holds true. Now the zero vector yielding v, a zero vector is basically a point, so there's nothing to be added, and so anything plus 0 is equal to that anything, and so that's all that that's stating. Opposite vectors, that's important. So if I have an initial point and I go to a terminal point and I call that v, the opposite vector would go from a terminal point to from an initial point to a terminal point, but it would be the exact same vector in terms of magnitude, but the direction would be opposite. And so when you add them, what ends up happening is I'm going to go from the initial point to the terminal point and then turn around and go back. And so I just end up right at a point. So that's all it's basically saying there. Okay. So just some scalar rules. This is something you guys should look at. 0 times a vector is going to be 0. 1 times that vector will be that vector. A -1 scalar is going to make that a negative vector. So it's going to be the opposite of the vector that's being multiplied. And then there's some distributions that are demonstrated with scalars. You should know those. That is something that is going to be beneficial. Okay, so for this example here that I'm about to do, I'm going to first name some vectors for you, and we're going to use those vectors in order to demonstrate these problems. So what I'm going to do is I'm going to say that's the initial point, and this is the terminal point, and this is the vector. So this vector for me is going to be my v vector. This will be my initial point from my w, and it's going to go to a terminal point. So this will be my w. So now using these two vectors, I'm going to generate my problem. So I'm going to start at what would be my origin. So I'm going to say that this is the origin, and I'm going to go v. So v is going to be this piece here, right? That's my v. And then minus w. So minus w, what it's going to do is it's going to take w, but it's going to reverse the order of it, right? The direction it's going to go. So instead of going down like it is here at a diagonal, it's going to go up at that diagonal. So let me see if I can do it. It's going to go to here. So this is going to be my negative w. And so the resultant is from that initial point to here. And that is v minus w. That's how you're going to construct these guys. Okay, so the next one that we're going to do is, again, using those same two vectors that we just drew, the references for v and w. I'm going to use those to do this b problem here of 2v plus 3w. And so again, I'm going to use this as my origin. And so there's that. So this is, that is 2v. And then plus 3w. So plus 3w is going to take us here, and then here, and then here. So then what's going to end up happening is that is 3w. And so the resultant vector is starting at that initial and ending at the terminal point of the two vectors. And so this is 2v plus 3w, and that is the answer to this problem here. Okay, some more information for you to know. These are going to be useful formulas for you to know. This here is the property of the magnitude of V. So when you see those double absolute values, really what's that's saying is they're looking for the magnitude of V. So that's something important for you to understand and know. And we'll use that. Now, another one that's going to be important is this one right here. When we have the magnitude of a vector and it's equal to 1, it's got a special name. It's called the unit vector. And that's going to be very, very useful for us as we move along. And then this is just notation. So vectors are written like this. Instead of using parentheses, they use these type of brackets. And so we'll go ahead and do that so you can see. And I'll try to explain that to you guys in some of the examples I'm about to do. So, well, you'll see it in just a second. Okay, so one of the important things to talk about is a position vector. And a position vector, what it does is its initial point is at the origin. So if I have this point here, and this point is the origin, then any vector that I draw is going to be a position vector because it is its initial point is at the origin. So just some terminology, but it's going to be important and useful to know. Here's another theorem that's going to be useful. And this is basically just telling us if we have two vectors, this is the formula that we're going to use in order to be able to give a vector. So let me do an example using this theorem. And so it's asking us to find the vector from P1 to P2, point 1 to point 2. And so to do that, V then is going to be a negative 1. It's going to be 4 minus a negative 1, comma, 6 minus 2. And so our vector is going to be 5, comma, 4. And I'll show that to you guys so you guys can actually see what that is. We could actually plot these points. So if I said this was the x-axis, this was the y-axis, or we can call them I and j since we're talking about vectors. And I'll delve into that in just a second. So the point negative 1, 2 is right here, and the point 4, 6 is right here. So what ends up happening is you have this vector and this vector, and when we surmise these guys, what we end up with, and we'll be able to see it, is the resultant vector is this guy right here. But that resultant vector is going to get shifted to here, and so that tells us we're going to go over 5, 4, and that should be the vector that we want, because we want it to be, and it makes it a position vector. Point 1 plus point 2, the resultant vector of that being shifted to the origin gives us this guy right here, and that is our answer. Okay. Two vectors are equal, and it makes sense that they're equal if they have the same component parts to them. That's all this theorem is saying. Basically, you can see if we have a vector v with a sub 1 and b sub 1 and a vector w with a sub 2 and b sub 2, well, if a sub 1 is equal to a sub 2 and b sub 1 is equal to b sub 2, it makes sense that it's the same vector, one and the same, so it's not a big deal. The unit vector, this is another way to write it as ai plus bj. I and j are the coordinates, kind of like x and y. So I is along the x-axis and j is along the y-axis. And so that's how the unit vector will be written. And we end up seeing that it is, the components to it are 1, 0, and 0, 1, which we'll get into truly understanding the unit vector more and more. I guess I can give you something about the unit vector. The unit vector, its magnitude is always 1. And that kind of shouldn't surprise you. That's like the unit circle. So there's a connection there. Now, this thing going forward, these formulas 2, 3, 4, and 5 are going to be very, very useful. And so I'm going to use those right now to do these two examples. And so in this first example, A, I'm going to be doing V plus W. And so V plus W is going to be using this formula up here. And so what it tells me to do is to take the I components, so 2 plus 3, and then parentheses with I, plus the j components, which would be 3 minus 4, and then put them together. So I'm going to get 5i minus j, and that is our vector. Now, another way to write that thing is we could also write it as 5 comma negative 1 with these I don't know what to call those things, the triangle shaped looking things, inequality looking shaped things. Either one of those would be acceptable as answers for this as a vector. So that's just the way you do it. So here's B. With B, we're going to end up using this equation, and so it's telling us to subtract V from W. So in this one, I'm going to go V, or 2 minus 3 I plus 3 minus a negative 4. That's J. And so I'm going to get negative I plus 7J. Or I could write that as negative 1 comma 7. So it's really not that bad, right? The notation behind it isn't that bad. Again, we're going to use those formulas to do another set of examples. And so here, for A, I'm going to take a scalar 3 times my 2i plus 3j, and so that will give me 6i plus 9j, or I could write that as this right here. Not bad at all. For B, it's telling me to go 2 times my v vector minus 3 times my w vector. So that will give me 4i plus 6j minus 9i plus 12j, which is going to give me a negative 5i plus 18j, or a negative 5 comma 18 in that notation. Okay, Now it's wanting us to find the magnitude. That's for part C. And so to find the magnitude, that's simply the square root of the coefficients of I and j. So with v, it's going to be the square root of 2 squared plus 3 squared, which is going to give me the square root of 4 plus 9, or it's going to be square root of 13. There it is. Not too bad. Okay, so the unit vector, the way we can find it is the unit vector is going to be the vector divided by its magnitude. And so to find a unit vector for any vector v that we're given, all we're going to do is take the vector and then divide it by the magnitude. So then my u in this example is going to be 4i minus 3j divided by the square root of 4 squared plus a negative 3 squared, which is going to give me 4i minus 3j over the root of 16 plus 9, or 4i minus 3j square root of 25, and we know that to be 5, so I'm going to go 4/5 I minus 3/5 j, and that is our answer. This would be the unit vector for that v, the given v vector that we have. All right, let me do one more example for you guys, and this is to find the angle. And so one of the things I'm going to do so you guys can see this is I'm going to actually graph it so you guys can see. So this is going to be my I, this is my j, or the x and y axes if you like. So there's 1, 2, 3, 4, and then 1, 2, 3, 4. And so we have this point here. That is our terminal point. And starting at the origin, we get this. And here's the important piece. We have to remember the angle is based off of the y or the x-axis, and it's counterclockwise. So this is our alpha angle, and so that's what we're looking to find. So we can see that our alpha angle is going to be something kind of big, and so going back to some trig that we already know, the tangent of the angle alpha is going to be equal to y over x. So our y in this case is -4, our x is 4, and so tan of alpha is going to be equal to -1. So alpha is equal to tan inverse of -1. And since we're talking about an angle here, we can talk about it in terms of degrees. And so we'll say that alpha is 315 degrees. You could use the unit circle to go ahead and find those values. In fact, on this exam, when we take this exam, you're going to be allowed to use as many notes as you want. I'm not going to restrict you. So make sure you take some good notes and use them well for the exam. I will give you a practice exam beforehand so you can use those notes to prepare for this exam. I hope this has been beneficial. As always, all the best.